Hi, my name is Kaylee Burt, and this is my Physics 2 Lab Report 1, Charge Tapes. In this lab, I will demonstrate how you can give charge to neutral objects by using two pieces of tape and then calculating the excess charge on one of the pieces of tape. And I will also show how I modeled the same experiment in the code I created in GlowScript and then talk about my results. A little preview of my results: I determined that both tapes are negatively charged, so therefore there will be an excess negative charge from electrons on the tape. And then the charge on tape B that I calculated was negative 1.4 times 10 to the negative 8 coulombs, and the ratio of number of electrons to atoms I calculated was 43.75 electrons to atoms. Physics principles I used for this lab were Coulomb's law and Newton's second law to calculate both the electrical force and the gravitational force on the tape, and then I used the concept that net force equals 0 to compare the electrical force to the gravitational force, and that helped me to calculate the electrical charge on the tape. Initial conditions: the system is tape B, the surroundings were tape A, support, books, my hands, and everything else. The length of the tape was 0.2 meters, the mass of the tape is shown, and then the distance between the tapes when tape B was hovering above tape 1. Calculations: this is kind of the steps I used to calculate the charge on tape B. First, I calculated the gravitational force on tape B, and then since net force is equal to 0, gravitational force has to equal the magnitude of the gravitational force is equal to the magnitude of the electrical force. So I used that concept to calculate the electrical force, and then I worked backwards to calculate the charge on tape B by using the magnitude of the electrical force on tape B. And then here's the calculations how I got the ratio of electrons to atoms. I just divided the excess charge by the charge of an electron and then got that number, and then I calculated the number of atoms on tape B and then divided those to calculate the ratio of a number of electrons to atoms. Here's my GlowScript code, or half of it. First, I just established the constants I was going to use in my code and then made the two tapes, and I'm considering them as point charges, so I just created spheres for both the tapes, and then I assigned gravitational force to g-force, and then I created a gravity arrow, or just an arrow to show the gravitational force, and printed out the magnitude of the gravitational force. And then I calculated electrical charge, printed that value, and calculated also the tape charge and printed that value, and then also calculated the electrical force and printed that value, and assigned the tape charge I calculated to both tapes. And then I wrote an electrical force function just so I didn't have to find the electrical force of each tape separately. I just created a function, and then I called it twice just to create the electrical force arrows on each tape. Some assumptions I made: we ignored air resistance in the computational model and then treated each tape as if it were a point charge with all the charge concentrated at the center, which is why a sphere is used to show the tape. And then I assumed that each tape had the same amount of charge evenly distributed. And then here are my results from my computational model. You can see the arrows in purple are the electrical force, and then the arrow in pink is the gravitational force on tape B. And then I got the same magnitude of the charge on the piece of tape as I did in my original observed experiment. And so similarities between the two, observed versus computational: I calculated the same charge on tape B and then the same magnitude of gravitational force and the magnitude of the electrical force. The difference is GlowScript is just more accurate, had more decimal places in the calculations, and then I was only able to use the GlowScript code because I calculated some of the values in my first experiment, like the mass of the tape and the distance between the two tapes. And then some potential sources of error: we didn't account for air resistance on the moving tape, which could have affected our results, and then treating the tapes like point charge with all the charge concentrated was helpful for the experiment but could have made the results inaccurate. And then also I didn't have an isolated environment for the experiment, so the tape did come in contact with other objects. And so the what if and why: the what if electrons had positive charge and protons had negative charge, nothing would change. The tapes would still have like charges and they would repel each other, and the observations and results from the experiment and the computational model would still be the same. And then it's important to handle the charge tapes as little as possible because the charges are temporary and were created within the experiment, and when the charge tapes come in contact with other objects, their charges will be just distributed to other objects into the environment, and the experiment just wouldn't work as well. Thank you.